Hi everyone, I'm Karan Bansal, and this is Hardening AI Coding Agents with Hooks. Here is my one-line pitch for the next half hour. The guardrails that actually hold up around AI coding agents do not live inside the model. They live in the harness around it. This is a field report, not a theory talk. Everything I show you is open source, MIT licensed, and running on my machine right now. Let's get into it. Quick credentials so you can calibrate how much to trust me. I am head of AI at Armor Code with 10 plus years in security, founding engineer at Avid Secure, which Soph was acquired. Before that, I ran security and privacy at Urban Company. I've spoken at DEF CON and OWASP chapters. The line that actually matters for this talk is the last one. I maintain Claude Code hooks, the open source repo everything in this talk is built on. 476 stars as of August 18th. The table on the right is my other open source work. One rule for every number you will see today: pulled fresh, never from memory. Here is the problem in one line. An AI coding agent is a developer with no judgment. Think about what we handed on day one: your shell, your files, web fetch, MCP servers, git push, and it can spawn sub agents so it recurses. Every single move is the model's call, and it happens at machine speed, dozens of actions a minute. Now put that next to the adoption numbers. 90% of developers already use AI at work. Only 29% trust the output, and Veracode's compilation puts a vulnerability in 45% of AI generated code. So we are handing right access to something we do not trust. That gap between what we grant and what we trust is what this talk is about closing. 4 dates from this summer tell you exactly where we are. August 4, the chain drop, warm backdoors, more than 400 NPM packages. And here is the detail that matters for the storm. It persists by planting a session start hook in .cloud/settings.json. The agent's own config file, a file security scanners never read. The worm weaponized the exact mechanism the talk is about. July 16, Hugging Face discloses an end-to-end breach run not by a human operator but by an autonomous agent swarm at machine speed. June and July, the cursor dunes light CVs go public. CVSS 9.8. Zero click prompt injection all the way to OS level code execution. One flaw overrode the sandbox's own helper binary, the other broke symlink resolution. And on August 3rd and 4th, the OWASP ships the LLM top 10 for 2026. With excessive agency, the risk this whole talk is about, up at number 3. This talk got easier to justify and harder to ignore. Before any defense makes sense, one concept. Every AI coding agent from every vendor runs the same loop. Think: the model picks an action, act, the harness executes the tool call, observe, the result goes back into the context window, then repeat dozens of times a minute. Here is the part most people miss. The model is a black box. You cannot patch policy into its weights, and prompt instructions are suggestions, not controls. Anyone who has watched an agent cheerfully ignores its system prompt knows this. So, security has to happen between the steps, between act and observe. At the exact moment, a decision becomes an action. That seam is where everything else in this talk lives. Now, the reality check. The textbook's answer is a sandbox, and the textbook is right. But in practice, almost nobody runs one. People launch agents with skip permissions. They click allow all by minute 3. They work in their main dev environment because the sandbox breaks CI and half of their tooling. And lately, the story got worse because even the shipped sandboxes failed. Duneslide overrode the sandbox's own helper binary. Cursor had a git hook code execution flaw, CV 2026-26268. And the Pocket OS incident, an agent holding one overbroad railway token deleted a production database and its backups in about 9 seconds. 9 seconds. That is the machine speed part made concrete. So here is where the hook set. If you skip sandboxes, hooks are your enforcement layer. If you don't, hooks are your second layer. Either way, you want them. So here is the architecture. Hooks are checkpoints. The harness fires at fixed points in that loop. On the left is the full lifecycle diagram from my blog post. The middle panel zooms into the agentic loop where the decisions actually happen. 5 hook types: command, HTTP, MCP tool, prompt, and agent. And the contract is deliberately tiny. Execute 2 blocks the action. Exit 0 with JSON returns a structured decision. Hooks run in parallel. Synchronization by default, asynchronous when you flag them. I want to stress how boring that contract is. JSON in, JSON out, exit codes. That boringness is a feature. It is exactly why every major vendor converged on the same shape, which I'll show you near the end. Cloud Code now exposes 31 hook events. 31. You do not need all of them. 6 carry the security load. Pre-tool use is the big one, the enforcement point before anything executes. If you remember one event name from today, make it that one. Post-tool use inspects results after the call. User prompt submit screens input before the model ever sees it. Permission request intercepts privilege escalation, instructions loaded watches context files as they load into the session. And the last one, config change. It earned its place on the list this summer. Config files became an attack surface. Chain drop made sure of that. Who guards the guards is now a real question, and we'll get to it properly in a few slides. Let's look at the anatomy of one call because this slide is the whole mechanism. Left slide, the harness pipes JSON to your hook on STD in tool name, the full arguments, session ID, working directory. In this example, the agent wants to run rm-rf on a projects folder. Right side, your hook writes JSON back, permission decision, deny, plus a reason in plain language. That reason gets fed back to the model so it adapts instead of blindly retrying the same thing. Now notice what is absent from the slide. No prompt, no LLM in the middle. The hook is a separate process the model never sees, which means it cannot be jailbroken and it cannot be social engineered from inside the prompt. That one property is what everything else in this talk builds on. 2 weeks before this airs, OWASP shipped the 2026 LLM Top 10. So let's key the whole story to the new list. Same 10 risks, new order. The moves that matter here: excessive agency jumped from 6 to 3, unbounded consumption climbed from 10 to 6, improper output handling fell from 5 all the way to 10, and system prompt leakage got renamed to hidden context exposure with a wider scope. One caveat before you quote me: the claim that this re-rank was weighted by real incident data is secondary sourced. Verify it against the official PDF before repeating it. My scorecard stays honest. 6 of the 10 have a hook-shaped answer today, 5 covered, and the top row says bounded on purpose. Nobody reliably prevents prompt injection. Hooks decide what an injected agent still gets to do. 1 is conditional. 3 are genuinely out of scope at runtime, and I would rather tell you that than pretend. The headline: the list moved towards the tool boundary, which is exactly where the hooks sit. OWASP also gave agentic risks their own list in December, the top 10 for agentic applications. If the LLM list is about models, this one is about actions. Hooks land squarely on the four highlighted entries: ASI02 tool misuse, ASI03 identity and privilege abuse, ASI05 unexpected code execution, and ASI09 human agent trust exploitation. And note the line at the bottom: OWASP's own analysis says prompt injection touches 6 of these 10. Prompt injection is not getting solved this year. So the practical move is not preventing injection, it is bounding what an injected agent is allowed to do. Which brings us to the hooks themselves: real code, shipped, and tested. First shipped hook: block dangerous commands. A pre-tool use hook on bash. What we are looking at is the actual pattern table from the repo. Each entry has an ID, a regex, and a human readable reason. RM targeting your home directory, DD writing to a disk device, a fork bomb, curl piped into a shell. 3 safety levels: critical stops catastrophes only, high adds risky operations like git reset hard, strict adds the cautionary tier, and you set the level per install with an environment variable, no code edit. And my favorite part: graduated ask mode arrived as a community PR. Instead of a flat deny, a level can escalate to the human, so you decide the gray zone instead of the model. On the 2026 list, this is LLM03, excessive agency, up 3 places. And the chip in the corner is real: 1570 tests, green on August 18, 0 NPM dependencies, MIT licensed. Second shipped hook: product secrets. Two pattern families doing complementary work. File patterns catch reads, writes, and edits of .env files, SSH private keys, and cloud credentials. Bash patterns catch the sneaky path, environment dumps, and exfiltration over curl, SCP, rsync, or netcat. The allow list at the top matters for usability. .env.example and templates stay readable so the agent can still do its job. No LLM, no network call, pure regex, and one script covers read, edit, write, and bash. This hook alone carries 145 tests as of August 13 repo audit. If your rule is that an agent should never read your credentials, this is about as cheap as real enforcement gets. Now, the genuinely new attack surface, and if you take one new idea from this talk, take this one. Your agent's config files are now malware carriers. Trapdoor plants zero width Unicode instructions inside claude.md and .cursor rules files, invisible to a human reviewer. Detection averaged 5 minutes and 56 seconds after publish, and it still landed. Chain drop from slide 4: plants is persistent hook in .cloud/settings.json. And CB 2026 25725 showed sandboxed code injecting persistent hooks through settings.json itself. The attack configures the defender. The hook answer shipped this week. Config guard blocks the agent rewriting its own guardrails at pre-tool use, and config watch writes the config change event for everything else. Watch the files that configure your agent, including the hook config itself. The platform answer is workspace trust, which gates hooks in untrusted folders as a version 2.1.218. And the chip is current. Both hooks are in the repo. Code you can run today. This is my favorite hook in the repo because it targets agent behavior rather than attacker behavior. Here is the failure mode. An agent under pressure to make the build green will sometimes just delete the failing test, or rename it out of the test log, or slap a skip marker on it. The build goes green, the evidence goes away, and you find out in the production. I call it the fake green problem. Protect tests community PR20 blocks all three moves. 30 seconds on its sibling, case insensitive guard because it is such a clean example of folks knowing what models do not. On a case insensitive file system like APFS, RM-RF lowercase content can take out capital C content. A hook can know that about your file system. The model reliably does not. Hidden context. This is your Claude.md, your system prompts, your hidden policy files walking out the door. OWASP renamed this risk in 2026. System prompt leakage became hidden content exposure, and the official scope widened to developer instructions, RAG schemas, and the hidden policy logic. Two attack shapes. One, the instruction you load get exfiltrated. Two, the nastier one, prompt injection through the file system where something writes rules into your config for the next session to obey. The instructions audit hook writes the instructions loaded event and pairs with product secrets. It ships this week 11 detection rules, including the zero width Unicode signature trapdoor used. Observability quickly. Session logger writes a durable markdown log of everything the session did, and the plugin reorders run with async true of the critical path secret redaction built in. One framing note to keep the OS mapping honest. This is incident response and forensics, not misinformation coverage. There is no tool called to intercept when a model hallucinates. The point is narrower and more useful. Being able to diff what the model claimed against what actually happened on disk. The performance rule that makes all of this deployable: sync when you decide, async when you observe. Enforcement hooks sit in the loop's critical path so they get a budget under 100 milliseconds. Observers get no seat in that path at all. They run async, no budget needed. Here is why the budget is not optional. An agent making 60 tool calls throughout a 200 millisecond sync hook burns 2 full minutes of pure weight. And slow security gets disabled by the very people it protects. Every security engineer watching has seen that movie. Keep the deciding path fast, push everything else off it. So, do hooks actually meet that budget? Fresh numbers measured August 17 on my machine, not asserted from memory. The flagship hook end to end process response to pass JSON verdict, median 31.7 milliseconds, minimum 30.4, maximum 34.3, 20 samples, Apple M3 Pro, Note 26.5, comfortably inside the 100 millisecond budget. And most of that time is node process startup, not the pattern matching. The repo commits a benchmark harness to. Its number for this hook is 33 milliseconds median. Same story, reproducible on your machine. And the newest trick, a guard pack, all 6 guards in a single node process. Run separately, they cost about 199 milliseconds per call. The pack does the same checks in 38. The runtime ladder below still holds qualitatively. Bash starts fastest, Node is the sweet spot, Python is the heaviest sync choice. Compiled languages come in under 10 milliseconds. The ladder figures on screen are May 2026 measurements, and they are labeled that way. One machine, 1 week, dated. That is the standard most slideware skips. Enough architecture, let's watch hooks actually fire. 3 clips, all recorded in a throwaway sandbox with fake credentials. Clip 1, I asked the agent to check our Stripe keys. It goes straight for .env, denied with a reason. Then watch it hunt. It tries grep side doors, masks its own output, gets denied again, and settles for the sanitized template. Exactly where we wanted. Clip 2, curl pipe to a shell. Let's see what happens. It gets blocked cold. Now, a gray zone command. As we can see, the ask mode escalates it to me. The human decides the gray zone. Clip 3, a failing build and the agent tries to skip the failing test. The fake green gets blocked. Notice how little the friction there is. These hooks are invisible until they matter. Zoom out from my repo to the industry. Because the pattern 1. Every vendor converged on the same three moves: deny by default egress, OS level sandboxing, and policy checkpoints at the tool boundary. Cloud Code ran a hardening sprint through July and August, strict allow lists, credential masking, fail closed batch checks. GitHub shipped security validation for third-party coding agents in June, layered on the Copilot agent firewall, on by default, with org level controls since April. Codex agents now run offline by default during the agent phase. Below all of this sets the kernel layer. Projects like Nono on Landlock at 3.7 thousand stars, plus eBPF monitors and MCP proxies. Those compose with hooks rather than compete. Hooks are the application layer checkpoint, and there is now academic backing for deterministic pre-action authorization, the archive reference on screen. The repo is built in the open, and honestly, the community ships faster than I do. Git safety, protect tests, format code, and ask mode all arrived as outside PRs. And case insensitive guard grew out of a community idea. 5 external contributors merged. The fifth, a shell injection hardening fix that landed this week. The repo today: 12 hooks, every one a command plugin install, plus a guard pack that runs 6 of them in a single process. A 20 plugin marketplace, 1570 tests, CI on node 18, 20, and 22, 0 NPM dependencies, 476 stars, 34 forks. And my ask is targeted. 19 of the 31 hook events still have no coverage at all. The config guard slide 14 called for shipped this week. The one I want next is a caps hook for unbounded consumption. If you write one hook this year, write that one. 4 things to take home. 1. Policy runs outside the model in a separate process it cannot see. 2. Enforce between act and observe at the tool boundary. 3. Sync decides, async observes, and the deciding path stays under 100 milliseconds. 4. Guard the guards. Watch the files that configure your agent because attackers already do. The repo, the blog post, the hook stock, and both OWASP lists are on screen. Everything is MIT licensed. Fork it, break it, send me a hook for one of the 19 events still uncovered. I am Karan at the rate karanbansal.in. Thank you for watching.